So we're going to do the extrema values. So chapter 4 becomes an application of derivatives. Basically, it helps you find local maximums and local minimums of any function, really. So like if you have some curves, let's see if I can find a good example or picture. Can you guys see the grapher?
Yes.
Okay. I'm going to use just a basic sine function. So let's pretend that this function was something else, right? Ignore the sign or whatever it is. This peak here and this valley are potential maximums and minimums. So we call them critical values because these are the locations where the derivative will be equal to zero because the tangent line has horizontal slopes, which means a slope of zero, right? Um, so you can use the derivatives to help you find these locations. If they are the absolute maximum or minimum, we call them global max or min. If we don't know if they're just peaks and valleys, like let's say the function shot off up here and then shot off down there forever, right? Clearly there is no minimum or maximum, but there's a local max and local min. Does that make sense? That's essentially what we're gonna do on this example. So let me go ahead and start a homework problem. Okay. Here's a good one. I think it's the earlier one. I think it might be one of the first ones. I don't remember. So f of x is equal to x plus 3 to the 2/3. I'm going to skip the derivative steps just to save time. So I'm going to assume you know how to find the derivative. And then we're going to create the steps. Okay. All right. Let me double check the homework problem. I think it's this one. I think it's number 3. Yeah. Number 3. Just different numbers. All right. So first step, step 1. They're not asking. No, I guess I'll make this question asks for what? If not, I'm gonna make it my own here. Yeah, that's not interesting. Yeah, I'm sorry. I'm gonna choose a different question. Let's start with an easy one, and then I'm gonna give you the steps. So given f of x equal to x to the fourth minus x cubed, find the critical numbers. Okay, so step one. Find f prime. So that would be this, right? You guys agree? Double check me here.
Can you explain it briefly, please?
The derivative.
Mhm.
So we're just doing a power rule, right? You bring the 4 down,
Mhm.
subtract 1 from the power.
Yes.
Bring the 3 down. 3 times 8 is 24, right?
Yes.
Subtract 1 gives you 2. So just do the power rule from the beginning of chapter 3,
Oh,
this term and that term.
thank you.
So that's step 1. Step 2, set the derivative equal to 0 and solve for x. These values will be the critical numbers. Actually, give me one moment, please. Give me like 5 minutes. I'm sorry. All right. So first step, find your derivative. Second step, set it to 0. Because remember, this means uh, slopes are equal to 0, and that happens at horizontal tangents, which means it happens at peaks or valleys. That's why this is chosen. Okay. So now solve for x. So we got 4x cubed minus 24x squared equals to 0. Okay, factor the 4x squared. That's all I see in common, right? Yeah. So you get x minus 3. No.
Do we not get 6?
Yeah. Yeah. Sorry. Thank you. So we get set each piece to 0. This means x is 0 and x is 6. Okay.
So the 4x squared equal to 0, it's 0 because if you divide by 0, it becomes 0, right?
Which one? This one?
Yes.
Well, the only way this will be 0 is if x is 0.
Oh,
If you solve for it, divide by 4, 0 divided by 4 is 0. Square root, both square root of 0 would be 0. So nothing really changes if you work through it. But 4 times 0 is the only way to get 0.
all right.
Critical numbers are x equal to 0 and 6. Any questions on the step 1 and step 2? I factored 4x squared. That's it.
Is that the final answer?
Yeah, that's all they asked for. The exemptions. Exemption. Oh, sorry. No, critical numbers.
All right.
Okay. Let's do another one. This time we will find the absolute extrema of a function. So extrema is just another name for maximums and minimums. Let's see. I think we need another page. You guys are cool in this one, right?
Yes.
Okay, let me find another one. Okay.
Your screen is blurry.
Yeah, give me a second.
It's good. Blurry. Yes.
Okay. Find the absolute extreme. So basically that means the local, the global or absolute maximums and minimums. Okay. That's all extreme I mean. Just the peaks and valleys. And those happen usually at critical numbers. So now we're going to find the critical numbers and then determine what is the maximum and minimum point of this function. X cubed minus 3/2 x squared, but we're going to look at it only on a specific interval. So when they close it off like this, so that we're not looking at every possible point, just this specific interval, then absolute maximum and minimums can happen on the endpoints. So step one is still the same. So let me write a note here. Maximum and minimum will occur at the endpoints -1 and 6 or critical numbers. So we gotta find the critical numbers and then just plug them into the function and see what is the biggest one, what is the smallest one. That's it. Because it's a closed type, that's all you gotta do. Step one, find f prime. The derivative will be this. You guys agree?
Yes.
Okay. Step two, set the derivative equal to 0. So that'll give us let's see, make a little more space. So for x, so we have critical number at 0 and at 1, right? Okay, so for this type, step 3, plug in x equal to 0, 1, -1, and 6. And determine what is the max and min.
So we are plugging in the number given to us and the number we find for x.
Yeah, you plug in the critical numbers and
Mm-hmm.
the endpoints.
Oh,
So there's a theorem in, I think, optimization that says any function on a closed interval may have a max or min at the endpoints. It's not guaranteed, but it is common that it will be on the interval. So always check.
okay.
So all you got to do is plug them in. So f of -1. We'll use the original function, of course, because we're trying to figure out how big it is. So that'll be what? -1 plus, no, minus 3/2, which is what, -5/2. Plug in 0. That'll be 0 cubed minus 3/2 times 0 squared, which is 0. F of 1 is equal to 1 cubed minus 3/2 times 1, which is 1 minus 3/2. So that'll equal negative, what is that, half? Yeah. F of 6, that would be 6 cubed minus 3/2 times 6. Let's use a calculator here. That'll be, so really cares. 162. Okay, so looking at these numbers, what is the smallest one? What is the minimum?
The -5. 5 to the 2.
Yeah, this one, right?
Yeah.
So the minimum is at -1 comma -5/2. Um, Maximum.
162.
Yeah, so at the point 6 comma 162. Yeah. So those are the absolute minimum and maximum, which are both extrema. Any questions on number 2 on the process? Does that make sense?
I just didn't get how does -1, -3 over 2 equals -5 over 2. Same for f of 1.
This one?
Yes.
Oh, well, -1 is -2/2 minus 3/2. So that'll be 5.
Okay.
So change
So
this.
change the formula for -1, right?
I'm so sorry. I hope that wasn't too loud. Excuse
No
me.
problem.
Um, -1. You got to do the LCD.
Okay.
You do change it to 1/1, multiply by 2/2. This becomes a -2 minus 3, which is -5.
Okay.
Same.
Okay. Yes. Thank you.
Okay. All right. Let's move on to the next one. No other questions?
No questions.
All right. Give me one moment.
I think it's example 3.
Sorry about that. Okay. Here's another one. going blurry on me. Find the absolute extrema of, let's do another one. 3 cosine x at 0 to 2 pi. So as a closed interval, everything will be the same. Alrighty, here it is. So step one, I'm just going to write number one here. Find the derivative. What is f prime?
To move the 3 to the power of x.
The 3 is just times the cosine?
No, cosine x cubed.
No, just do the derivative of cosine. When you have a 3 on it, you can just ignore it.
Oh,
Just do derivative of cosine.
oh.
So what is the derivative of cosine? You guys remember? Yeah, it's going to be negative sine. So you're going to have the 3 times negative sine, which is negative 3 sine. Step 2, set f prime to 0. That will be negative 3 sine x equal to 0. Divide both sides by negative 3, and then you get to here. Right? When is sine 0? So this is a pre-calc question. You guys remember? Right, from 0 to 2 pi, 1 revolution around the unit circle. Where is sine 0? It's going to be at 0 and at pi. 0 and 180. So these are the critical numbers. So now do the same thing as before. Step 3. Plug in x equal to 0, pi, and 2 pi. That's okay. I know a lot of the answers, a lot of the outputs are 1, but the angles are not. I think you had it backwards. Okay, so just plug them in and see what's bigger, what's smaller. F of 0, that's going to be sine.
A quick question. Where
Yeah,
did we get the 2 pi from?
from the endpoints.
Oh, I'm sorry. I'm really sorry.
That's okay. So we take the endpoints and the critical numbers. It just turned out that this critical was also an endpoint. So we only have 3. Those 3 sine 0 is, what is sine of 0?
I think it's 0.
Yeah, right. We just did it right here.
Yes.
So That should be cosine. I messed that up. That's the issue. So what is cosine of 0? Because we got to do the original, not the derivative.
Cosine of 0 is 1.
Yeah, now it's 1, right? Then at least. Cosine pi. That's going to be,
-1?
yeah, f of pi, 2 pi rather. Cosine of 2 pi will also be 1. Although, what did I forget here?
Nothing that I see.
Forgot the 3.
Oh,
There should be 3 times 1.
1. Yes.
3 times 3 times 1. So, absolute max is at 0, 3, and 2 pi 3. Technically, these are the same location, but it did include 2 pi, I think, in the interval, so I'm going to use both. Absolute minimum is going to be the smallest one, so that'll be here, right? So any questions on this process? Alrighty, let me check the syllabus. It's been a while.